Greetings to everyone. Today we are here to talk about the effects on strength of soft clay treated with fiber and cement. First of all, introduction. There are different type of soils and some of them have good bearing capacity while others don't, and there are some cases where soil is not suitable for construction. Engineers have the choice to improve the soil quality either with replacing it with superior soil or improving the soil's property by mixing it with materials like cement, lime, or other cementitious materials or byproducts. However, to further increase the tensile strength of soil, reinforced fiber can be used, and by means of this, the compressibility of the soil can also be altered. Next, talking about the scope of research, this research will determine a relation between the peak strength of soil and residual strength, and also be covering the effect of introducing fibers to increase the peak strength of soil, meanwhile treating it with cementitious materials to enhance compressive strength and activity. This study will help us determine the influence of fiber on ductility and brittleness of soil, and how the mixture between fiber and cement can be altered to maximize the strength while using sustainable and reusable products. Efforts to develop a relationship between confining stress and cohesion angle is also made in this attempt. Next. So now talking about the reinforced soil from the figure 1, it could be seen that the soil with no steel fibers peaks at around 1.5% of axial strain. But with the increase of steel fiber, the value of axial strain varies from 2.8 up to 4, with 10% of steel fiber being used in untreated soil with 20% cement. Similarly, from figure 2, it could be seen that the unconfined compressive strength of soil increases with the amount of cement used as 10, 15, and 20% respectively from the graph. Next, talking about some background researches and results, the behavior of soil changes significantly by the fiber type and amount of cement used. And by altering these values, the peak strength, stiffness, and brittleness can be altered. It could also be computed that with the increase of cementitious content, and the brittleness index can also be increased. However, it decreases with the increase in fiber content up to a peak value. It could also be seen that the cohesion and angle of internal friction are significantly influenced by the percentage of fiber content used and then amount of cement or lime used. So additional fiber content plays an important role in this development. Adding a particular confining pressure value, the shear strength increases with increasing fiber content in the case of cementitious treated soil, while peak strength value was observed when the fiber content was 0.1% in the case of lime treated soil. Now Manish would take over.
Hi. From these graphs, it could be seen that the untreated soil possesses unconfined shear stress, and with the increase of an addition of fiber content, the horizontal values determine the fiber content, and values represent the shear strength. The condition in the graph indicate that there might be an optimum fiber content that, in the case of the unconfined shear strength, is 0.1%, which correspond to the maximum strength of lime-treated soil. This is possibly due to the reduction of a number of hydration reactions that are produced in the soil matrix caused by the domination of fiber in the matrix when using the fiber content exceeds 0.1%. Additionally, when the fiber content reaches a limit value, the overlap and binding of fiber may result in the unevenly dispersion of fibers and create some weak interfaces, thus reduces its strength. Now, talking about the existing studies, it could be seen that from comparison of data from various researchers, the value of cohesion and internal angle of friction increases with the introduction of fiber content and cement because of the interfacial forces and interlocking properties between fiber and soil particles. There are several other studies that shows that the optimal fiber content peaks out at around 0.25% to 0.5% in the case of cement reinforced soil and further increasing fiber correspond to sticking with each other. That will result in creating lumps, which will impede the cementation and fiber bonding, thereby limiting the efficiency of the strength enhancement. Now, talking about the brittleness index, it is a term utilized to indicate if the soil sample is brittle with the withstand structures and provide resistance against failure and can be computed by the equation that is given by Consoli in 1998, that is IB equal to axial stress at failure upon axial strength stresses -1. Now, methodology, unconfined compressive strength and the indirect strength of cement treated soil have been investigated and specimen data from other researchers have been computed in this research. And it had been compared for peak strength of soil that will influence this question of quantitative data for the researchers that is being taken into consideration. Both qualitative and quantitative researches from various researchers are considered and how they impact and influence the results of this study. And there have been a finding of relation that will uh, vary with the different variables and their effect of soil strength can be computed after this research. Now, talking about the laboratory data, since the laboratory data has been taken from other researches because we don't have access due to COVID, and they have been taken into consideration, and it could be seen that the undrained shear strength of soils alter with the introduction of lime and cement. The data and other research shows that in the case of untreated soil, the undrained shear strength peaks at value of K equals to 0.25. When the soil is treated with lime, the strength peaks out at around 0.1. And similarly, when the soil is treated with cement, the value of K maximizes at 0.5. Now Rahul will work on the next slide.
Yep, hi. From these results, it could be seen that the brittleness index increase with the amount of cement, but decrease with the increase of fiber content. And at least 15% axial strain, the undrained shear strength for untreated soil peak at 0.25%, while the one treated with lime peaks at 0.1%. And similarly, the soil treated with cement peaks the ultimate shear strength when the fiber value is 0.5%. Next slide, please. These are various methods of testing the soil properties, and most of them are accessible in laboratories. Some of these are direct shear stress and the commonly used test to determine the shear parameters of soil. The second is triaxial comparison test, which is used to determine soil's shear parameter under any drainage condition. The third in the list is unconfined compression test, which is a special case of triaxial comparison test in which the confining pressure is considered zero and can be conducted only on saturated cohesive soil, which can stand unsupported without confining pressure. The fourth is vane shear test, which is used to measure undrained shear strength of soil with low shear strength. The last in the list is borehole shear test, which is field test to determine the in situ undrained strength of soft place in which the borehole shear device is instead started to into the borehole and expanded into the soil using compressed air soil sheared, and the corresponding load is determined. Next slide, please. Application of engineering problems. With the help of treated soil, the strength properties of soil can be altered under improved stress strain curve can be achieved, which helps us to build a structure on a load bearing soil capacity. It could also help in development of post cracking strength since fiber impose interlocking properties. The unconfined compression stress test strength and tensile strength can be increased significantly. With the introduction of cement and steel fiber, and the value of brittleness index and activity can highly altered by means of this can also introduce innovative method to reduce the cement uses in deep soil mixing projects, thereby minimizing the carbon footprint and overall cost of construction. Thank you.